Hello and welcome to this lecture where we are going to finish the implementation of single tracking. Just a reminder that in the last lectures we created this code to select the algorithm we are going to use. Then we defined the bounding box or the bbox variable, which is responsible for selecting the object that we want to track, which is in the first frame of the video. Now we need to go through each one of the frames of the video to continue tracking the objects until the end. We can implement a while loop, while true. I will redefine the OK variable and also the frame video.read. Every time we call this read function, we will move on to the next frame of the video. Take a look here that in this part, we call the read function, so we have access to the first frame of the video to select the object we want to track. And when we put this code inside this while loop, we are going through each one of the frames. First, we get the first frame, then the second, the third, the fourth, and so on. Let's implement an if statement. If not, okay. If it wasn't possible to read the next frame of the video, it means that the video has ended. So we can just break the execution of the while loop. This code is used to stop execution when the video ends. In this part of the code, we are initializing the algorithm with the first frame and the first position of the object. And every time we read a new frame, we need to update the location of the bounding box, because in the next frames of the video, the object will be in a different position. So we can recreate both variables, OK, and bbox equals tracker dot update, and we just need to send the frame. And this is not the first frame. This is the second, the third, the fourth, according to the size of the video. We use the first frame just to initialize. And after the initialization of the algorithm, we need to update the location. We can also take a look at this variable, OK, and bbox. Let's run this code. I will select the runner, press enter, and we can take a look here at some information. We have here the first position of the object. This is the initial bounding box that we selected using the selectROI function. And after processing every frame of the video, we are updating the position of the object. This is the first position, X and Y axis, and this is the second position in the second frame of the video, in the third frame of the video, in the fourth frame of the video, and so on. See that these values here are not changed because they are the size of the bounding box, and it keeps the same size until the end of the video. And we can take a look here at the message. It means that the object could be tracked, and this is the new position of the object each one of the frames. And here is the last position of the object. We can also print the OK variable here just to see the value equals false. Let's run this code again. Select the runner, press enter. We can see the results here but we just need to put the OK variable after reading the frame. Let's run again. Select the runner, press enter, and let's wait until it finishes processing all the video. At the end, we can see false, which indicates that we couldn't read any frame anymore. So it means that the algorithm could process all the video. And then the break will be executed to stop the while loop. Let's put these two prints in comments. And now let's see the results in the video. If OK equals true, if we could read and track the object, we will draw a rectangle to see the results. Let's create the variables x, y, w, and h equals, in the format of a list, let's convert to ints, int v. I will create this variable v now for v in bbox. It means we are accessing this variable, which is composed of the x and y axis and also the size of the bounding box. And we are copying each one of the values to each one of these variables. For example, this first value will be copied to variable x, the second to variable y, the third to variable w, and the fourth to variable h. We can just see these results, print x, y, w, and h. Run this code again. Let's select the runner, and we can see here the results. We are just copying each one of the values of the bounding box to each one of these variables here. And now we can draw the rectangle on the image. CV2 dot rectangle. We can use this OpenCV function. The first parameter is the frame. Just a reminder that every time we run this while loop, we are getting the next, and the next frame. So we will put the rectangle in each one of them. The next parameter is the first position, x and y, which means the initial position of the bounding box. The next parameter is the final position of the bounding box. So we can put here x plus w, which is the width of the bounding box. This number here, we are just adding this value plus this value. And then y plus h. We are adding this value plus this other value here. The next parameter is the colors variable. As we saw before, we are defining random colors to draw the bounding box. The next two parameters are related to the size of the bounding box. For example, 2 and 1. In some seconds, we are going to perform some tests changing these values. If it is not okay, if we couldn't update the bounding box with the next position, we will print a message. CV2 put text frame. Let's type tracking failure when the algorithm was unable to track the object. The other parameter is the position where we are going to print the message. The next one, CV2 font Hershey simplex. This is the type of the letter, the size of the letter, the color, in the BGR format, 00255, and finally the thickness of the ladder, number 2. And finally, CV2, I am show to see the results. Tracking, this is the name of the window, and let's put here the frame. If CV2 dot wait key, this OpenCV function is used when we want to type a specific key. For example, we can type here this symbol 0xFF. This is a hexadecimal code. If it is equal to 27, then we can break the execution. This number 27 means the ESC key in your keyboard. So when you press ESC, we are going to break the while loop so the window will be closed. Now let's test again. Run. Let's select the runner. Press enter. And we can see here that the tracking is already working. Of course, we can see a problem here because we are using the boosting algorithm. We can press ESC in the keyboards to close the window. Let's first try with the MIL algorithm, which is index number 1. Run this code again. Let's select the runner, press enter. See that every time we run, we have a different color here because the colors were defined randomly. And see that we have a problem because we selected the yellow runner and the algorithm started tracking this other runner. And it happens because these two first algorithms aren't so good. As we saw in the intuition lectures, they are the most simplest algorithms to track objects. So the results won't be good in all scenarios. Now we can perform some tests using these parameters. For example, let's change here from 2 to 10. Just to see the results. Select the runner, press enter. As you can see, this is the size of the bounding box. Let's move again to number 2. And actually, this last parameter we don't need to specify because it is the type of the line. For example, if you want a dashed line or a solid line. So we don't need to worry about the last parameter. And the same for this one here, we can just erase. And we cannot see this message tracking failure because the bounding box was generated. Of course, it wasn't around the objects, but the algorithm could still generate in the bounding box. We get this message only if we can't update the next location of the object. In the next lecture, we will perform some other tests and we'll check when we will get tracking failure. Finally, we can just put another message on the frame. I will copy and paste this code here. Let's put here the name of the algorithm, tracker type, the positions 120, and we can keep the other parameters. Now let's run this code again. Select the runner, press enter. We can see here at the top of the video the name of the algorithm. So it is nice to see the name of the algorithm in order to check the results. And in the next lecture, we will perform some tests using all algorithms. See you there!